When we solve this simple circuit, because we have 4 resistors, it's going to take several redrawings of the circuit to get our equivalent resistance. I've already filled out my VIR chart, and I know that because I'm only given the voltage and nothing else, I will have to go through the steps of finding equivalent resistance. So first step, figure out what combinations or what resistors you can combine most easily first. And that would be the 5 and 6. You definitely wouldn't want to combine any of those with the 2 ohm resistor yet, because it's in parallel with both 5 and 6. So we have to simplify that down before we can combine it with the 2. So again, I know this is tedious, but it's always helpful to redraw the circuit. I know that 5 and 6 are in series, so that has 11 ohms. The 2 stays the same. And I'm drawing this circuit a little bit differently because I see there's a junction there, and I usually like to draw that as a T-junction like this, which you don't have to do, but for me, that's just generally the way I like to visualize my circuits. So right now, I'm just plugging in all the other circuits that are left in my number 6, and I have to do another step of combining. This one right here, the most obvious to combine are the 2 and 10, which are in parallel. So I have to add the reciprocals, and then once again, when I add the reciprocals, I have to take the reciprocal of the answer. So this right here would be the R equivalent is 1 over the sum of the reciprocals. This would give me 1 over 12 over 22, which the answer would then be 22 over 12. That gives me 1.8. And when I redraw my circuit for a third time, and this is the last time, I can draw the 1.8 in series with the 10. And that's very easy to simplify because that gives me a total resistance of 11.8. Now, as I look at the answer key, they get 11.7. I think there's probably some rounding differences there with what they got and what we got, but if you see that you have a slight difference that's pretty small, then it's probably not an error, it's just rounding a little bit differently. Okay, so now we can start filling in our blanks. I have a row at the bottom that is blank. Again, the VIR chart is helpful because I am solving for current, which is voltage divided by resistance. That's 12 divided by 11.8. I get 1.02. I'm just trying to keep the same decimals as the answer key here. Again, there's slightly different than ours, but that's okay. And then from there, we have to conceptually figure out how the other components of the circuit. So I'm going to go here and I am going to kind of draw in what we figured out. We've got a total current coming out of the system of 1.02. And we know that the current is going to split here, but we also know that it's going to come back together at this point and also be 1.02 at the bottom and into the battery. That allows us to fill in the current through the 10 ohm resistor as also 1.02. And therefore, we can solve for the voltage of that through that resistor or dissipated in that resistor, which would be 10.2. Okay, the next thing that we can analyze is the fact that this resistor dissipates 10.2 volts. What that leaves us is 1.8 volts for the rest of the loop. And unfortunately, I have 3 resistors to think about, but if I've already dissipated 10.2 in this one, I have to analyze the individual loops. So as I go through the loop with the 2 ohm resistor, in total, that should dissipate 12 volts, which means that the 2 ohm resistor is going to dissipate the remaining 1.8 volts that's left over. So, or actually not 1.8, it's 0.8. That's left over to give us a total of no, I had it right. I am looking at the answer key and it's mixing me up. This should be 1.8 through the two ohm resistor. 1.8 through the 2 ohm resistor. I just put my resistance values in a different order, so it is going to look a little bit different than the answer key. But from there, I can solve for current, which is 1.8 divided by 2. That gives me 0.9. For the current. And one thing that we want to think about is if the current through here is 0.9 and the total current coming in is 0.02, then we know that the current through both these branches should total up to 1.02. So if I subtract 0.9 from that, I end up with 0.12 amps going through both the 5 ohm and the 6 ohm resistor because they are in series and the path is the same, which means the current is going to be the same. So this one right here is going to be 0.12, also 0.12, and then you can figure out the voltage by multiplying IR together for both of those. I end up with I'll just calculate it because we have a little bit of a rounding error here. So I got 0.6 for my voltage through the 5 ohm resistor and 0.72 voltage through the 6 ohm resistor. And